Hope you are safe and healthy. On behalf of ISC Bangalore students, I welcome all participants to third day of Limit Camp. Today's student lecture will be given by Ankan. Ankan had previously given a lecture on first day of camp on the topic complex numbers. I welcome him back to speak on guide to problem solving. And a few things, Akan will be speaking for about 1 hour, and later we reserve 20 minutes for questions. Uh, so please feel free to ask questions. Type them in the chat box. We'll combine them and ask later. Yeah, that's it.
Thanks for the
Akan,
introduction.
over to you.
Today I will be presenting some problem solving techniques, and problems will be pretty basic and well known. Some are pretty well known, but I will be discussing the concepts and mainly some kind of puzzling questions will be here. Well, let's start then. The problem one. There are three numbers ABC. This question is pretty simple. Some optimization question, but it's pretty simple. You need to convert A to X, B to Y, and C to Z such that XYZ forms an arithmetic progression. Okay, XYZ will form an arithmetic progression. That means actually XYZ will form an arithmetic progression. That means Y minus X equal to Z minus Y. That is what we are gonna get. And the only allowed operation is to increase each number by 1. That means you can make A to A plus 1, then A plus 1 to A plus 2, or B to B plus 1, C to C plus 1, like that. Or each will be counted as one operation, increasing any one number by 1. And you can use this operation in A, B, and C as much as you want. Okay. Find the minimum number of operations needed. Now what I will like to do, that you can actually solve it, try to solve it, or say something the way you are going to approach it. The way must be pretty good actually, that not only solves this problem but also many kind of problems. Can anyone tell? Just try and tell the idea.
Do you know any property of the numbers A, B, and C?
No, A, B, and C can be any number, like 111, 1, 1000, 2000, any number, just integers.
So is the answer in terms of some variable or is it a definite answer?
The answer will be in many cases of ABC. And answer will be in ABC, forms of ABC.
I think we will have to increase only two of the three ABC, because if we increase all three, then the difference again becomes the same. So I think we'll have to increase.
Can you tell a little louder?
Hello, sir.
Yeah. Can you tell a little louder? Okay. If you can't make it any louder, you can say like that. You say.
Yes, sir. So I think that we'll have to. We don't have to increase all three of the ABC, because if we do increase all three ABC by one, then like the difference will remain the same. So we will have to increase only two or one for the minimum number of
Yeah. But what will be the minimum number of operations on depending on ABC? You have that answer will be an exact.
Sir,
Yeah,
Sir, I
yeah.
think we can do it in this way. Sir, suppose we have that A greater than B greater than C. So then if we see the difference between A and B and the difference between B and C. So the one which will have the greater difference, will keep them as it is, and for the other number, if we means if the smallest number, like C is the smallest numbers, and suppose the difference between B and C is less than the difference between A and B. So if I increase the sorry sir, if the difference between B and C is more than that, or if we means if after that if I increase the B in such a way such that the difference between B and C would be equal to that of between A and B.
Yeah, that's one case done. And one simple thing you missed, that the difference between A and C must be even. If it's odd, you are gonna increase C by 1 or A by 1. You have to make it even, right? ABC are integers.
Yes, sir.
Yeah, that's the case for A greater than B greater than C. For other cases, okay. Then let's
Sir,
just,
I think for AP, the main idea is to make A plus C equal to 2B.
yeah.
For that, we can adjust it. Like we will take the C constant and then adjust the A in such a way that it becomes the sum becomes even, and then adjust the value of B.
How can you say that will be the minimum? Minimum number of operations will be needed. Okay. Let's make it. Okay, let's discuss this then. Uh, one kind of visualization we can do is, I am trying to make a straight line here. Suppose this is a straight line. Okay, I don't need this much, and along this region, the value of A and B and BC will be there. What we are gonna do is, uh, here the value of A will be there, here the value of B will be there, and here the value of C will be there. Okay, we have to make it as a straight line, and it will be, I mean, this distance and this distance are same. So what we are going to do is we are going to make a straight line of angle of 45 degree. Then only this difference and this difference will be same, like that. So there will be uh, cases like A greater than B greater than C. There will be another case where, well, we don't need like that. We will be needing A greater than C, and under it there will be two cases. Okay, B is less than C and B is greater than A. There will be three cases most probably, and okay, clear, right? Hello, anyone? Clear?
Yes, sir.
Yes, sir.
Well then, for B less than C, what you are gonna get? Uh, For b less than c, I am already taking a is greater than c. Okay, so let's take here a is greater than c and b is somewhere here because b is less than c. Okay, this axis will be denoting the value. Okay, value is increasing on upper direction. Okay, so what we are gonna see that this difference between a and c, if it's even, well, probable case, if a is greater than c by 1, then also okay, but any, if greater than c by even number, not 1, I mean greater than c by even number, okay, then we have to do nothing, just increase the b. Okay, that's all you need to do, because that's the minimum distance you're gonna cover to come here. Clear, right? But if the difference between a and c is okay, I just changed this question into minimum distance. Okay, and this is actually a technique you can use in any other kind of question. This is a pretty basic one. um, this, and if a difference between a and c is odd, you are gonna increase a by 1 and the difference will become even, and then increase b. Okay, fine, right? You can also increase c by 1 and then increase b. Both way, the number of operations will be minimum.
But sir, one thing, if in instead of increasing, oh, okay, okay, got it. Yeah,
Yeah, you can. You are thinking of decreasing, but the main operation is only
no, no,
increasing.
yeah, only increasing is allowed.
Yeah, yeah.
Sir, I have a question.
Yes, yes.
If difference between A and C is very big and difference between B and C is quite small, then instead of increasing B, we can oh, you can't decrease. Sorry.
Yeah, you can decrease. So this make the case where b is less than c, and for b greater than a, what we are gonna get? B is somewhere here, right? And in this case, you can only increase. So what can you do in this case?
In this case, we have to increase A.
Yeah, you have to increase. Yeah, increase. You can only increase a. So you can't. You don't need to take any extra steps here. This is not required. Yes. Then
So, no, sir.
the highest distance you can get here, so that you don't need to make b any bigger, increase the distance, is that you can make all of them in the same line. What does that mean? A equal to b equal to c, right? This will be the minimum distance, as c must be equal to b and a must be equal to b. That's the minimum distance you can get. Both can be less than b, so that's the minimum distance here. Okay, and
So, or they can also increase A, like only A. So that will also result in the same length.
yeah, yeah, you can make it in the same line. Okay, and this is the other case for um, so other case b greater than a is also done. Now the case is a greater than b greater than c, and someone already told this. Okay, so b is there, and you are just gonna make the difference between a and c even and place b there, right? That's not totally true actually. There's a it can be also divided into cases. Suppose b is less than a plus c by 2. Okay, so suppose b is less than a plus c by 2. Okay, always take, if difference between A and C is uh, odd, you are just gonna increase either A or C. Okay, but the better case will be to make A give +1. Okay, the upper range increasing rather than decreasing their own distance. Okay, but both way it will be same. Suppose A is less, B is less than somewhere here, and you need to take it here. So you can just increase B. Okay, fine. But if B is actually greater than A plus C by 2, somewhere here, then what you need to do is increase A such that the minimum shifts to B. Okay, I mean mean. A plus C by 2 equals to B. You are increase A like that. You're understanding how it will happen, right?
Yes.
So
So why can we not increase C by the same x? Means if we increase C also the same thing will only happen.
yeah, I said you can either increase A or increase C, right?
So sir, in that case, I think one thing will be a problem that C is much below, right? So if we want to increase C, then we need more number of steps.
Sir, but the same displacement will also be of the A.
Oh, no,
Yes.
no, no. In case B is greater than A plus C by 2, you can increase C. But keep in mind that difference between A and C uh,
Should be
doesn't
even
remain odd.
always.
Yeah, it will remain even, and if you are getting A greater than A equal to C, well, A is greater than C. If A is greater than C plus 2, you can do it pretty easily. But if somehow you increasing C, it actually crosses or almost reaches ABC, you have to make some algebraic manipulation and then prove that it's the minimum, but that will be harder. Increasing A will, you don't need to prove anything. Increasing A, understanding it, right?
Yes, sir.
Yeah, so increasing A, making the range safe, actually it's safe to keep B between A and C. So you can increase A, that will be better. And so it was done, but what's the formula for B less than C? uh, the formula will be something like, okay, suppose A and C's difference is already made even, and then if it's even, then you could just A minus C is odd, then the what will the formula? Anyone can tell me right now? Now, anyone?
So what about B? What is the condition of B?
B is less than C. I'm doing this right. I'm doing only this right now.
So is it A plus C minus 2B plus 2 the whole divided by 2?
Yeah. Okay. This is the formula. don't know why this happened, but and this is for even. You can get it right. Why? Okay.
Yes, we need to increase one because if a minus c is odd, and for even we don't need to increase that either of a or c by 1.
Yeah.
So it is a plus c by 2 minus b plus 1, right? That minus b plus 1 is in the numerator after the.
No, it's not remainder actually. It's something like
Yes,
this. Okay.
yes, about.
So actually, you can do the other cases like this pretty easily. And if b is greater than a, I mean, b is greater than a, you just need to reverse the whole thing, right? Just make ABC CBA. Number of steps will be the same. Okay, make it CBA and b will be again less than c. Less, you can see why, right?
So one thing in the given case, when if a minus c is odd, then I think a plus c will also be odd.
Yeah, that's why you're increasing a by 1. Oh, sorry,
Then
sorry. Okay,
I
okay,
think
sorry.
the bracket,
That will, yeah, that will be 1. That will be 1. But I mean, the final a will be greater than 1, right?
yes,
Yeah.
now it is okay.
You have to increase the a by 1 also. Thanks for the correction.
So for the even one, why are we again increasing by 1?
Oh, sorry, you're not increasing. What I am doing. It's okay. Thanks. Okay, basic idea is that one. And if b is greater than a, you can see b is above a. You're just gonna reverse the whole thing. Just turn the whole graph 180-degree. Okay, b will be less than c again. You can see why, right? Hello, anyone?
What case are you taking?
I'm taking this case, b greater than a. You can turn the whole graph upside down. The graph I drew, this one. You can turn it whole upside down by 180-degree. You can see that if b is greater
Yes,
than a, it will
taking the
become,
reflection.
yeah, yeah. You can totally make b less than both a and c.
You can reflect it about x-axis.
Yeah. Like if you take b less than, see, you can see that b will be here, b will be greater than. Okay, the minimum number of steps will be the same, right? As the reflections number of steps will be also same. That's why. So I'm not writing any formula. It will be upside down and then the same formula. And for a greater than b greater than c, the formula, I should actually write it down. A minus c equal to odd. Minus c equal to odd. You are gonna increase uh, increase the number of steps by 1 and then arrange the order. I mean, if if b is actually oh, there are also two cases here. Two cases here.
I tried B is greater than A, but the exact answer is not the same as B is less than C.
B less than C. No, exact answer is not. It's the same. Exact answer is not the same.
Oh, okay.
because if you reverse the whole thing, uh, basically taking reflection will reverse the whole thing, right? ABC will be CBA.
Yes, sir.
Yeah, so you have to change A to C and C to A, right? Something like that.
Yes.
But uh, yeah, yeah. Even if you change C and A, it will be remain same because yeah. Yeah, it will be same.
Sir, but the
Only,
diagram.
only the value of B will be different because changing C and A will not make any difference, right?
But sir, could you go back to the graph you drew? The one for the second case.
Yeah.
Yes, sir. Sir, A C should be below A, right?
C should be below, C should be above A. You are
Sir,
taking, no.
A is
Okay,
greater than B.
okay. Wait. We are taking the reflection of this one over above one, and below one's reflection is above. And now say,
Yes, sir. So for the second case, you had told that you have to increase A such that C such that A, B, C are all equal, right? Like for them to be in AP.
no. What does app? In none of it you are gonna make A and B, A, B, C equal.
But even if we increase A like to the straight line to make all of them in straight line, then also, sir, I'm getting 2B minus C minus A. 3 minus C
Yeah,
0.
yeah. Oh, no. In case of if you take reflection, then increasing will become decreasing, right?
Yes, sir.
You're getting it right. So you are gonna decrease in the reflection if you're gonna increase in the normal one, in the original one.
Okay, sir.
Okay, even the process will also reflect, right?
Yes, sir.
So if B is less than A plus C by 2, okay, I'm not writing for odd. You keep that A minus C is even. Okay. If A minus C is even, then number of steps will be just okay. And for the other one, you are just gonna increase A by 1. Uh, and for the other one, you are just gonna increase all 1. Like if B is greater than A plus C by 2. Yeah. Can anyone tell me now? What will be the answer?
So A plus 1 plus C by 2 minus B plus 1.
No. You are not remember the graph. What will happen if B is greater than A plus C by 2?
Oh, sorry.
It will be C minus, it will be B minus C plus B minus A. Both will be in the same line, right? B is if B is greater than A plus C by 2. No,
Yes.
sorry. No. You are gonna increase.
So I think 2B minus A minus C.
Yeah. A plus 2 into B minus 2 into C. 2B minus. You are gonna take the difference between C and B. What's the
Yes,
difference
we
between?
shall adjust C, keep the B constant, then A plus C is 2B. Keeping the B constant, then the sum is 2B, and then subtract A. It will
Yeah,
be the new value of C, and from it subtract the earlier value of C.
yeah. That's yeah. That will be the case. Difference between B and A, and then writing it. This will be the answer for it. And this will be done for A and C. Okay. Now if we take
So why is it becoming minus 2c and not 2b minus c minus a?
because B greater than C.
So can you show this case one?
Anyone? You can see right from if B is greater than A plus C by 2, then obviously 2B minus 2C will be greater than A.
I think 2b minus c, not 2c.
Minus, it would be minus
Yes, sir.
C.
I also think 2b minus c.
Oh, I actually take C, okay. Something like that. Uh, yeah. C plus 2B minus 2C, then it will be giving the range.
So
I
can
mean
you
C
let me
plus
one
2B.
shortcut on that?
Yes. If it will be the C plus 2B minus 2C, something like that. C plus this distance is 2B minus 2C. Yeah. Okay. This distance will be like that. So A greater than C is done. For C greater than A, you are gonna take the same case actually. If A is greater than C and C greater than, you can just uh,
So
rename.
is the AP allowed to be decreasing or does it have to be?
Yes, say.
So is the AP allowed to be decreasing?
Yeah. It's allowed to be decreasing.
Okay, sir. So then it's the same thing.
Yeah, it's the same thing. You're just gonna same thing, or if you wanna use the same formula, you can just change interchange A and C. It's not reflection anymore. It's only interchange A and C. That's all. And if A equal to B equal to C, one case is remaining. A equal to C. If A equal to C, then you can see only you are only gonna change B, or you are only gonna change A and C if B greater than A. Like this one, you're gonna take everyone to equal to A and C.
Sir, then the number of the cases will be b minus a or b minus c.
Yeah. That's all. The process question simple, but you are only gonna need to know how to change it into minimum distance. That's all. You can apply this idea in a later stage. Okay, then any question regarding this problem?
So could you explain the steps for the B greater than A case once? Just the steps.
You mean which one?
The
This
B greater than A sir, case.
A greater than C and B greater than A.
Yes, sir.
Okay. Uh, A greater than C and B greater than A. A is greater than C and B is greater than A. Take the value of B and increase C to B and A to B. That's all you need. You don't need to increase B, else you have to increase A and C both. Extra
Yes.
increase.
Okay, sir. Okay, sir. Okay. Thank you, sir.
Any other questions regarding this problem? Okay, then. No other questions, then I will be moving to the next question. Problem 2. It's pretty well known and everybody know this probably. Just a reminder like question. Everyone among you will be able to solve it. You have 16 black balls and 16 white balls in a bag. You put your hand in and remove two at a time. If they are of the same color, you add a black ball to the bag. Okay, you are gonna take either two black balls or two white balls from the bag, and if they are of the same color, you put a black ball to the bag. If they are of different colors, one blue, one black, and one white, then you add a white ball to the bag. What will be the color of the last single ball left? First, tell me, will there be a single ball left?
Yes, sir, because at each step we are decreasing the number of balls that.
Yeah, each step number of balls are decreasing by one. So you will reach a stage when it will be one. So now tell me what will the color of the last single ball and how?
So, is the answer black?
No sound is coming right now.
So I asked, is the answer, sir, when we remove two, then we don't put them back in.
Yeah.
So is the answer black? Black.
No. If you are gonna get two white balls, you are gonna remove this and you are gonna put a black ball inside.
Oh no, sir, I'm asking the answer. Is the answer black one? So because if we consider the white ball, then if we remove two white balls, then we will be adding a black ball. But so we be removing two white balls, so the parity of the number of white balls remains the same. But if we
Yeah.
remove a white ball and a black ball, then we'll put a white ball, so the number of white balls will be unchanged. So again, the parity remains the same. Since the starting
Yeah.
parity is 16, it will always be even. But so it never can be one, since so it can never be one. So the last
Yeah.
single ball left can't be white, so it will have to be black.
Yeah, it's all done. It's totally a parity question. One way is disparity, and the other way is taking the last two steps and check all this. This actually, in this case, you can get parity when there are huge number of steps like in balls. You are gonna remove in balls in the nth step, like those kind of questions. You
Can we use probability over here that the ball can be black? The probability of the first ball being black is half, and similarly the probability of the first ball being white is half. And we can similarly proceed further.
it's not half actually, but you mean in this case you are getting 16 and 16. That's why you can say half. But if it's not, you can't get half, right? You have to
Yes,
calculate.
I mean for this case it's getting 16 by 16 plus 16. So it's the first ball can be black.
Then the next step, tell me.
Then the probability of the second ball being black, that we can pick a black ball in the second attempt. The
Wait.
probability.
You are taking two balls. You are not taking one ball at a time. You are taking two balls at a time. Remove two at a time.
So, so you were telling about the second method in which we check the second last step. So then, so can you explain that method?
Yeah, I will be explaining it. You are always removing two balls and adding two balls. Okay. So reaching single ball, you have to reach two balls first. So number of options for two balls is this three. Okay. So just check. If you remove two white balls, you will put a black ball. If you remove one black, one white, okay, what we are gonna put? You're gonna put a white ball, and if you take two black balls, you are gonna put a black ball inside. Only this case remains, and you can see that actually you need to use the parity here, and the question is actually not right for a huge humongous. Actually, if the number of options getting huge, like you can put n balls in n nth step, you can see that only checking parity will not work. You have to check the nth step number of balls remaining. That's why,
Yeah, because we are not given the whether n is odd or even.
yeah. In that case, you need to check the last case you are getting. Like if you remove one ball in the first step and add one ball, second step you are removing two balls and adding one ball, then it will be n into n plus 1 by 2 minus n. This much of balls will remain in the last step, right? If you're going to remove the n plus 1th, that way you need to check n balls, and that kind of question you can't solve only with parity.
So, but if we use parity, then we can make two cases whether n is odd and n is even. Then for n is equal to odd, we have some ball remaining, and for n is equal to even the other. So
No,
then
you
we
have to
can have.
even no, you have to even check that there does remains n plus one ball in the n plus one step. And that alone cannot be done with parity, right? You have to check the condition suffices. You got my point?
Yeah.
Okay.
So
Okay.
can you go back to the question for a minute? Yes, Ankan.
Okay. Any other doubt or any other way you can solve it? You can
So
say.
sir, finally the answer is black.
Yeah. This case is the wrong case. And these two are correct cases. And if in
Parity arguments are enough.
yeah, say.
One parity argument is that a white ball is like an odd number and a black ball is like an even number, and so the parity of the sum of the balls in the box is remains the same that way.
Yeah, that's actually the real solution for this kind of this question. Someone
Yeah,
said a little while ago. That's the correct solution for.
that is one solution. I also thought of another.
Yes.
Uh, if you take out two black balls, you're putting back another black ball. So effectively, you're taking out one black ball.
Yeah.
If you're removing two white balls and you're putting back a black ball, so you're taking out two white balls and putting in a black ball.
Yeah.
And if you're taking out one black ball and one white ball, you're putting the white ball back. So effectively, you're taking out one black ball.
Yeah.
So whatever you do, you are taking out, or either you're taking out zero white balls, or either you're not changing the number of white balls, or you're taking out two white balls.
Yeah.
So at the end of any operation, there should be an even number of white balls in the
Not white
box. Yeah.
Yeah. Either
You cannot end up with one white ball in the box.
Yeah. That's the same as parity, right? The same as the previous one. Just you're taking white balls here in place of black. That's the same. And if here it is 17 black balls, then the answer will be white.
So even if it's 17 black
No.
balls,
Even at
it will be
17,
black.
it will be black ball. Even if it's 17, it will be black ball.
Yes. If it's 17 white balls, then it will be white.
Yeah. If you change it to 17 white balls, then it will be changed. Any other questions regarding this or any other problem in mind? Well, then let's move to the next question. Uh, Read this question properly. Okay. A and B are playing a game. There are n stack of coins. Suppose the number of coins in the ith stack be represented by ni. They will be playing alternately, and in each turn they have to remove one coin from any stack except the one which was chosen in the previous turn. There are n stacks of coins, and you can take one coin from any of the stacks. Okay, and it's this is given only to make sure that how many are on the nth stack. You don't need to bother about it. Just number of a representation for the number of coins in the stack. And you can't choose a stack which is previously chosen in the previous turn. Only in the previous turn. Previous to previous turn, you can choose that stack, but not only the previous turn. The player who is first to be able to choose any coin will be unable to choose any coin following the rules, will lose the match. Both players will be playing optimally, that's normal, and their winning strategy will be corresponding to their optimal solutions. N is a natural number. Now just tell me mm, tell me the strategy. Okay, even if you can't solve it, you can actually try. Just your idea. Well, probably you can't. You people can probably.
Yeah, you start with the smallest size stack, and then you keep playing in that only.
We can just aim to make each stack equal.
Yeah.
If we are able to make such an possible, I mean, when each ni becomes equal, then we can just play it symmetrically with the opponent.
You
So
have
all
played
A has to do, all A has to do is to just equalize every single ni. But if ni is already given, n1 is equal to given some n2 is equal to and so on, then obviously B wins, because if A can't, then just pick up, and then B will just play symmetrically.
Can you explain it again? Actually, I didn't got
If
it.
ni is equal to nj for
Yeah.
all ij,
Yeah.
then B wins the game.
For all ij then. Uh yeah.
Yes,
Correct.
then B wins the game. But if ni is not equal to nj, then all A has to do is to just equalize every stack. Means the height, and because every coin is of equality is assumed, so he has to just make the height of every stack equal, and then here and then B will make the first move over there again. So obviously A wins over here.
And will the opponent give him time to make all the stacks equal?
Sir,
Yeah.
if all piles are different, then he can the first player, if he starts and he keeps playing in the smallest pile. So
Yeah.
then he finishes one pile, then other player will be playing in some pile. Then next player again plays keeps playing in the smallest piles, like one after another, whichever is the smallest,
Yeah,
and he'll win then if all piles are different.
he will play in the smallest. Then
Yeah.
he will be losing the first, right? If he's playing in the smallest,
How?
because opponent will always get a bigger stack than him.
Yeah.
So
So
he will keep playing the
just
bigger stack.
yeah. So just consider two stacks. Uh.
One is
Oh.
bigger and one is smaller. Though he will lose first if he to take the smaller stack.
All right.
Okay, playing alternately. Suppose A is the first player. Okay, okay, you can take like this. You can remove from the another stack. Then the again will remove from another stack. But you can't remove once, and then you can't do this. You cannot take from the same stack. Okay. Uh, let me. These are the two cases. Now think. That is a floor function. Floor function is same as a box function, that is greatest integer less than or equal to n by 2. You will know box function, right?
Yes, sir.
Okay, okay.
What is capital N here?
Capital N will be the total sum total of ni, sigma ni.
Okay, so total number of coins.
Yeah, yeah, yeah. I should actually probably write it here.
Sir, one
Sir,
stack of sir, I got sir, one stack has more than floor of n by two coins. Then the person who is starting, if we assume that is A, then A will just choose that stack and just take coins from that stack because no matter what B does,
Yeah,
we
yeah,
will
yeah,
have
yeah.
to
You're
take the
correct.
other stack. So that is less than n by two. So
Yeah, yeah,
eventually
yeah.
we will be out.
But
Yes,
sir,
you are
we can't
right.
keep playing in one stack, right? That's not
No,
allowed,
no,
right?
it's alternate. Your A will play from that stack. B will take from another stack. You can't take from that stack. So A will again take from that stack because B has taken from any other stack.
Oh, okay, okay, sir.
That's a well. If number of stacks is one, then obviously B will lose. But don't we are not considering that. Okay. Now, for this case two, I think it's pretty easy actually.
Sir, for case 2A, all the stacks will have equal number of the coins.
Mm, no, 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 no. At most, I said at most. It can be different, right?
But if it is at most n by 2 coins, that means always either less than n by 2 or equal to n by 2.
Yeah, yeah.
So could you please show the question once? Sir, you said if there is only one stack, B will win, but won't that depend on the parity of N?
Nah, no, yeah, yeah, for only for n equal to
Yeah,
1.
for the for so if
Oh.
there's only one stack, then A will win, right? Like the person who starts.
So, but if N is even, like all the number of coins in that stack is even, then A will lose, right?
Why? You
So, sir, A,
just saw right. If one stack contains n by 2, more than n by 2, then A will win. That's actually a case.
Sir, is N the number of coins or the number of stacks?
Capital N is the number of coins, sum total of all ni's,
Okay.
and small n is the number of stacks.
So, Ankan, you can speed up a little, I guess.
Yeah. It will
If
already
they
work.
don't answer, then you can try to show the solution.
Yeah. Okay. Uh, anyone with any idea? I can then move on to the solution. Okay, tell me a final idea if anyone has. Okay, case one, everyone understood how to do it. For case two, if n is even, okay. In for this case, a can just uh, take from the highest size stack, and then b will take from another stack. Okay, and until a point will reach when it will become either you will reach case one or you will not reach case one. In that case, if you are not reaching case one, okay, if you're not reaching case one, then a point will reach when there will be only two stacks with one coin each. You understand why, right?
I didn't understand.
You understand it, right? Why it will reach to a one coin each.
So I didn't understand.
Didn't understand what you said. You realized why it will reach one coin.
Yes, sir. I think everyone will try to take the coin which has more number of coins from that stack. So ultimately, by playing in that way, it will end up with one coin in each of the two stacks. All
Yeah,
other will be gone.
yeah. So it will if n is even, then who is gonna win? B, right? Because the number of n is even, then ultimately there will be leaving only one coin, and there will be even number of steps starting with A. So A will lose, and in case of n, just take one. A will take one coin, and it will again become this case minus one coin, and then B will be starting. So B will lose. Understood, right?
Sir, I didn't understand. So I didn't understand n is even case.
Okay, if n is odd, you A will take one coin, and then n will be even. A will take one coin and n then will become even, and it will become case 2A again, starting, and B will start with case 2A now. So B will lose.
No, sir, I'm asking about case to A. N is even. So how? So like I didn't understand.
Uh, Suppose there are n by 2 coins, okay. Someone will, A or B will keep on taking coins from here. Either it will reach a position of case 1, right? Or it will reach, if it doesn't reach case 1, then what will you will finally be left with? It keep on decreasing, n is keep on decreasing in each step, and but case 1 is not reaching. Then you will definitely get one coin in two stacks, right?
Okay, so we are saying that there will come a point when there is two coins, but it can't be like two in one stack because then it will be case one. So that is why it's one.
uh, can you explain it a little? What do you understand?
So we are saying that there will come a point when there is two coins, but since we are saying that it's not case one, they can't be like two in one stack itself. So it will be one in one stack and one in the other, like that. Right?
Yeah, if, even if it's left with one coin suppose you are left with one coin in of, two coins in 16 stacks, okay. Suppose like that, two coins in 16 stacks. So, some that case, you will keep on taking coins from each stack unless it becomes to- two coins in four stacks like that, or one coin in one stack, three coin in other stack. If one coin in one stack, two coin in other stack, it will reach case 1A. You can see why, right?
Yes, sir.
Yeah, that's how. N is even, B will be ending the last coin, taking the last coin.
So if it reaches case one, then A will win. But if it doesn't reach case one, then B will win.
Yeah.
Yes, and for N is odd, it will just be the reverse.
For N is odd, A will take the first coin and it will reach case 2A.
Yes.
Yeah, you can see why it will still be in case 2, because if n is odd, then n floor of n by 2 is same as if n is even floor of n by 2. That's why it will still remain in case 2.
Yes. Understood. Thank you.
Well, this question is done then. Any doubt for this question or any other process you have in mind? Well then, we will be moving to the next question. Problem 4. You need to read this question carefully. The explanation is big. Probably I will not give you the whole explanation and will ask you to make the explanation yourself and send it in Discord or give you like a homework like that. But explanation is big. I will give you hints for this question. Okay, just read it. Suppose you have n cross m chessboard. You have to cover the whole chessboard with dominoes in such a way that no cell of the board is covered by more than one domino. Okay, that means no overlapping of dominoes will occur. You can place one domino on two cells and no other domino will be placed on any of those two cells. Okay. And no domino will cover any part outside the chessboard. That means it will totally fit the chessboard. Not one cell less, not one cell more than the chessboard. Okay. Pretty simple task. Let's make it more interesting, and you will be given a number k. You have to put k dominoes horizontally and remaining dominoes vertically. Okay, if you are given 2, k equal to 2, then you are putting k dominoes vertically and the remaining dominoes vertically. Okay. Uh, Okay, you have to also find anytime you know what values of k for it is even possible. Okay, for what value of k is it even possible? Can you tell a domain of k just by knowing n and m? Nothing. And think for at least I will be giving 2 minutes, 3 minutes, just for thinking the idea. Full solution you can think later and submit it, but just say the idea. The chessboard looks like this. Everyone knows, right? And let me explain. You can put a domino like this. You can put a domino like this. But if you had already put a domino like this or this, you can't put another domino like this. This is not possible because it's overlapping this region. It's not possible. And also you can't put a domino like this. It's not possible. It's outside the chessboard.
What is the dimension of the dominoes? That is,
Dominoes are 2 comma 1. It will cover
okay,
only
yeah, yeah. It's two on one, right?
like this. Just I draw. It will take only 2 cells, either horizontally or vertically.
So n by n chessboard means that n rows and n columns.
Yeah, n rows, m columns. Okay, this side is n, this side is n, and this side is m.
So what do you mean by the domain of k?
Domain of k, what possible values of k will fit? You can't say there are, it is a 1 cross 1, no, it is a, suppose 6, 8 cross 8 just in the figure, and you are saying that k will be something like 31. It will not be possible. There are reasons, I will explain why 31 is impossible. But think.
So can we tell that if n is even, then the minimum value of k will be 0?
N is even, then the minimum value of k will be 0.
So because then we can arrange each of the dominoes in vertically.
No, no, no. It's not n cross n, it's n cross m. Depends on m.
Check, suppose
So
we are
vertically
taking,
means that m will take one and along means one into two. So if it takes one in the horizontally and two in the vertically, so if n is divisible by two, then all the dominoes will be able to be fit as one cross two along the n that part.
Suppose m is odd. Okay. If m is odd and you are putting horizontally, uh, okay, okay, you are saying 0 horizontally, right? Yeah, yeah, yeah. 0 horizontally will suffice. Only in case m is odd, 0 horizontally will suffice.
And so if the so why if n is odd and not if n is even?
Actually, in along n it will be horizontal. I mean, okay, you can't turn the board. It will be as horizontal and vertical as meanings here. That's what I'm saying. If you put horizontally, all the dominoes you can't make. If n is m is odd, then there will be another row, right? And there will be one left. You can't put an horizontally anymore.
So you have to find out that k such that we can cover the board with k horizontal dominoes, and the remaining of them will be of vertical dominoes.
Yeah.
Sir, when both m and n will be even, I think k should also be even.
When both n and m is even, they should also be even. Yeah, that's a case.
Yes.
That can be a case. Yeah, that's a case. Just the domain of k will depend on the total size of n and m. That's okay. Okay, then
Sir, in that case, if m is even, then the maximum value of k should be mn by 2.
yeah, maximum case will be n by 2. Obviously, because dominoes are two size. Okay, let me give you some cases. One case is both n and m is even. Another case is exactly one of n and m is odd. Okay. Um, Obviously, you are getting why it is, because if n and m both are odd, you can't make, if n and m both are odd, you can't put even any number of dominoes because it must be even. Now tell me, for n and m is even in this case. Okay.
Sir, that case is done because I said that for that case k should also be even.
Is k is even for and k is less than mn by 2. No,
Yes.
it's less or equal to mn by 2.
Yeah. I mean, why k won't be odd? I need a proof actually, right? Why k can't be odd?
Yes. If suppose if k can be odd, then there must be odd number of places remaining over there on either side of a row or a column.
I said k is odd. Okay. You mean you will put like this, right?
Yes.
If I say if I can put like this, uh, if I put like somehow, if I put like this also, then
Yes, so if we, so I think, yes, we find out an odd number of odd case.
wait, can you say it more clearly?
So I think if we have an odd case, then the remaining rows will be odd.
No, I
Ye-
mean in any kind of scenario, it will not be possible. I'm just asking why would that be?
If k is
Because sir,
odd,
when
if
one
k is odd, then the remaining number of boxes will also be odd.
No, a domino will always cover two boxes. The remaining number of boxes will be even.
if k
I
is
mean
odd,
the I mean the number of vertical dominoes will be odd,
K is odd, the number of vertical dominoes will also be odd. Yes.
and then we can't cover the a single line completely, a single row or a column.
Yeah, one way it is correct. Yeah, one way it is correct. By it just depends on the factorization of n and m. Yeah. Well, that will do. And for one of n and m is odd, what will you do?
So I don't understand how you got the contradiction for when K is odd. I mean, what is the contradiction when you can't cover one row or column completely?
Uh, why? You mean if you put k odd, right?
Yes, so I didn't understand why. I mean, what exactly is going wrong?
Uh, in which one? N and m is even.
Yes, I guess so. The first case.
Okay, okay. Their explanation was if you put k odd, then it will also k odd dominoes. Then you have to put k odd vertical dominoes.
Yes, sir. So how are we getting a contradiction using that?
Hmm. Suppose you put k dominoes here, and even if you put like this or this, okay, the net length of net this region or this region will have uh, odd number of dominoes, or you will get somehow this region or this region, okay, will get odd number of uh, cells remaining. So you can't put anyhow, you can't manage both sides, right? Because k is odd. One side will get odd number of cells, and you can't put any more vertical dominoes to fill it.
So this is if any one of n and n are equal.
Sir, I think when exactly one of the n and m is odd, then k should also be odd.
A should also be odd. Why is that?
So I think if n is even, then k can't be odd. K has to be even. So k is the number of horizontal dots.
Yeah, yeah.
Yes, so if n is even and k is odd, then number of rows remaining are odd. So we can't fill that like with vertical dominance, because vertical dominance will occupy two rows. Even number of rows.
Okay, okay. Um,
So if n is even, then only even k.
okay, can you tell it again more clearly? I didn't got what you said.
So I said that if n is even, then k has to be
If n is even, then k has to be
even.
even. And why is that?
So because if k is odd, then oh wait, no.
Okay, everyone done with this one, right?
So can you explain this one again?
Which one? Which one? This one.
Yes, yes.
Uh, suppose you are putting any manner, okay, some dominoes, and if I uh, count each cell, like this cell,
The
this.
shared screen has been minimized.
Yes, yes.
No, we are seeing actually the audio part in the big screen, and the shared screen has got small.
Dustbin has gone small. What does
Is
that?
it? Is it for everyone?
No.
So I can still see
Yes,
the.
again it's fine. Again it's fine.
Okay,
Okay.
okay. You must be having some problem, but
Yeah,
it's
yeah.
okay. It's okay. Okay. You can see each row, and you must be by checking each row like that. Okay, you will be getting somehow in you must be getting in each column number of vacant columns must be even in order to put vertically the remaining you okay after putting all k horizontal, and if you are getting in each cell in each column actually in each column even number of cells, then you can totally say shifting the case you can totally shift say, putting this domino here and putting this domino here. Okay, you can totally shift it to here. And why is that? If you are getting even number of cells here and even number of cells here, then no wonder you can put here or here, that doesn't matter. You can even put it here. Okay, got my point? You can shift the dominoes, the horizontal dominoes.
So I'm still not
I think in the second case, the value of the parity of k depends upon the parity of m and n. So
Which
we
case?
make two cases where m denotes the column, means the column sum total. In the second case, I'm saying either one of m and n is odd.
Okay, okay. Let me finish this one up first. Okay, then I will be getting to that.
so I'm still not
Someone asked to describe it. So you got right. You can shift the k dominoes like that.
yes, sir, I got that. So,
Yeah, if you can shift, you can just enter the k dominoes like that until the whole column is fixed. Then you put another domino here, and as k, if k is odd in putting like this, you will get one row odd, and if k is even, you will get again even rows. So you can put the rest vertically. That's why k must be even.
yes, sir, now got it.
This is actually shifting procedures. Okay. Okay, now someone was saying something. Okay. Can you tell
Yes,
again?
so let the upper part, that is the row part, total the column sum, I mean, is n.
Okay, okay. You are saying M is odd.
Yes, yes. The first case is m is odd.
Okay, okay. Then the picture actually
I
tells
mean,
me.
you have to denote something. M is the column or n is the column. I'm just
Yeah,
saying
yeah,
that.
yeah. Okay, okay. M is odd. Then I think you need and take this one out of picture. Okay. This is your picture. Now tell me what you are doing.
Yes, so we are make the part is, this is, we are just calling it m,
Yeah.
and then the column, this the total column will be called n. So it depends upon m and n whether the what will be the parity of k. If n is, or if m is odd, then we can't completely cover it with a vertical domino. So there must be there must exist one at least uh,
You're close.
horizontal domino.
Yeah, you are
K,
close.
yes. So
But
and if m is odd, then there must be, and then k must be odd.
no, 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 no. No, no, no. Anyone else? The last one who said actually got pretty close. You have to, uh, uh, other than odd, you have to think about what you are gonna do about the odd part, cover up the odd part. What do you need?
So for covering up the odd part, we have to align the dominoes in such a way that uh, the side of the domino which is containing 1 will be along that side.
Yeah, yeah.
So the rest of the part will remain as even, and then it is divisible by 2, so we can put the other dominoes vertical.
Yeah, yeah. Something like that. Okay, let me explain. Okay. Suppose m is odd. Okay, you can write it without loss of generality also. Okay. Suppose m is odd. Then what can you do? Uh, what you need is something like this. You have to put vertical dominoes like that in same region as before. You can shift the dominoes, and after shifting you have to put vertical dominoes like that, and what you are left with now is the same question as before. You're understanding why, right? N and m are both even now.
Yes.
That was what I
Now it is
was.
easily divisible by 2 and we can align the dominoes.
Yeah, now k must only need be even. And so how many does it require? If m is odd, then you require n by 2. You need n by 2. K must be greater than equal to n by 2, and k even. You can see why, right? K is even as before, and here you need n by 2 k.
Sir,
Okay, sorry,
is
sorry,
it the
sorry, sorry,
case
sorry.
that
It will be uh, nm by 2 minus k must be greater than equal to, because k is the number of horizontal, so number of verticals must be greater than n by 2, greater than equal to n by 2.
sir, I have a doubt. Sir, in this case, n is even and m is odd, right?
Yeah, m is odd, and exactly one of m and m is odd, so n must be even.
Yes, sir.
So this is the case, and you can see if n is odd, then the just you need to the other case, the same as other case. You need then k must be greater than equal to n by 2. Understood, right? Why? You got it, right? Why k must be greater than n by 2? Because uh, if n is odd, this is the case for n is odd. You just need to put k domino, at least domino.
So, but when n is equal to odd, then k is odd.
When n is equal to odd, why k will not be odd?
So then, just consider one example for a grid of n is equal to some n is equal to
Oh, no, 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 no. Sorry, sorry, sorry. Yeah, yeah, yeah. Sorry, 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 sorry. Uh, this k is not even. Actually, this k is not even. This is the remaining k. Remaining k. I mean, for this region. For this region, actually, this k is k remaining is even, and this must be greater than equal to n by 2. Okay, okay. That is what. And their summation can be odd. Their summation can be odd.
Yes, sir. So the
Yes,
total
yes, I was
addition
just
can
thinking
be
that we
ordered.
can't say directly that whether it will be odd or even.
Uh, yeah, I can't say directly. I have to check whether n is a multiple of 4 or multiple of 2.
Yes,
Yes,
sir.
that is if so we have to make two cases whether 4 divides them n and or and 2 divides n.
Yeah. We have to check it like that. The remaining k must be even for this one.
Sir, can you please repeat how you got nm by 2 minus k is greater than or equal to n by 2? The inequality, I mean.
What did you say?
So how did you get the inequality for m is odd?
For m is odd, you can like this, right? You have to put k vertical dominoes. I mean nm by 2 is total number of dominoes, and you have to put vertical dominoes such that one row is totally covered. In case of m equal to odd, you need to cover one row so that it becomes totally odd, totally even cross even, right? So how many rows are there in, and putting dominoes, vertical dominoes to cover up the whole row, you need n by 2 dominoes at least, right?
Yes, sir.
And the remaining will be even cross even. That's all. And for the rest of the case, you can just do it like that.
Then what would be your conclusion that what the domain of k?
Okay, for this case, the domain will be k is even. That's all. And for this
And
case,
lesser equal to and lesser equal to mn by 2.
yeah. That's obvious. Is equal to n by 2. And for this case, you at least vertical number of dominoes must be greater than n by 2, and for the remaining k remaining must be even. So uh, okay, this will be n by 2 minus k must be greater than equal to n by 2, and k remaining must be even for m equal to odd. So k will be, what will be getting? There are remaining k will be even, and at least vertical. Oh, k will be even in this case. K will be even. You get it right. Okay, you get it right. I am just taking that number of verticals. You don't need this one. You don't need this one. Because the number of horizontal dominoes will be in k remaining, not in the vertical. I don't need vertical. I just need that k will be greater equal to even, and k is less than nm by 2 minus n by 2. Okay, you got it right.
Yes. So similarly for n is ordered.
Yeah. Because the number of horizontals is in the remaining part, not in the
So
other.
but so for n is odd, so that in that the k we can determine will be equal. But for n is odd we can't determine whether it will depend on
Yeah. In
n.
for inequality, or we can't determine like that. We have to check whether n is multiple of 4 or 2.
Yes.
Yeah,
Okay.
that's all. You can just check. K must, and one range is k must be greater than uh, k must be greater than equal to m by 2. Okay, and the rest depends on whether n is a multiple of 4 or 2, and that's like that.
So, Ankan, there is only 4 minutes left. Can we call it off, or do you have?
Okay. I will be doing a short question. It's a long question. You can see it. Taking up the
You can give it
homework.
as exercise, I think.
Yeah, yeah. It will be today's homework, and I will. Hey, Shanchan, is there any uh, today's
Wait, yeah.
problem?
There is no problem solving session today, but you can always
Yeah,
message him.
yeah.
Ankan is also a camp admin, so just message him. He is there in the.
Okay, okay. I will. I will then send it in the Discord. Okay. You can just try it
Yeah,
and
yeah.
tell
It's
me the
better.
solution.
You can send the whole PDF, na, whole PDF. You just make a PDF and send it.
Yeah, yeah, yeah. I will send the whole thing. You can check it once, and there's not much. There's some puzzle games, and you can check them. Like, uh, uh, like okay. One last question I will be giving. Just think about it. You don't need to see, and I will send the last question in the slide as a homework. But I will give another question here. You can just think about it. You have a sequence. Okay. Okay, but it's not that cell. Don't. This one will 1, 2, and 3, and n will be suffixes. Okay. There's a sequence like this, and n is greater than 3, greater than equal to 3. Okay. And do you know the Manhattan distance? D of I, comma A, comma I, uh, equal to comma I plus. Okay, suppose uh, the sequence P1, P2, P3, Pn. Okay, this is another sequence where Pi is equal to Ai, comma I. Uh, Understood it, right? What's Pi denotes?
So by that notation, do you mean the DCD or do you mean
No,
the
no,
pen?
it's actually a tuple, x comma y,
Okay.
like in a coordinate plane. Okay. Uh, so the distance between Pi comma Pj equal to distance between Pi comma Pk plus distance between Pk comma Pj. Okay, where
So these are points on the coordinate thing.
I didn't get what you said.
So are these
So,
the points in the coordinate plane?
Yeah, 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 you can. It's not points. You can write it as points. There's no worry. Okay,
Ankan, do
okay.
one thing. You write this question nicely and put it up in the slide and send it because it's already 2:30 and I don't want to drag it.
Okay, okay, I can end it. It will not be problem.
Because you are just typing, na. Anyway, it would be better if you just put it. Problem.
Actually, I don't want to give it as homework. Actually, it's just better to think. It's
Yeah,
not
yeah. They will think after seeing the slide. It's not a homework.
okay. It's well, time is a pretty important thing. I don't want to waste it. Actually, they can have questions. Okay, if you have any question, I will be on Discord. You probably won't be understanding it question if I just write it and give it to you. Okay, you can ask me questions in the Discord then. It will be better. Well then, uh, we will be ending this session right now here. Right now here then. Uh, you won't be understanding the question, and you can ask anytime. I will be probably answer you within